Establishing facts about the angles created when parallel lines are cut by a transversal. So I've actually done a couple other videos where we talk about parallel lines and a transversal. There's quite a few of them this week, like finding angle measures given two parallel lines cut by a transversal, identifying corresponding and alternate angles, solutions involving angles and a pair of parallel lines, solutions including, solving equations involving angles and two pairs of parallel lines. So there's been quite a few parallel line and transversal type videos this week. One of my main things, and I've said it in all of these videos, yes, you should be taking notes. You need to understand what all of the pieces are and how they, what the properties are and how they respond to each other, or react, I guess you should say. How the angles relate to each other. That's a much better word. How the angles relate to each other based on the parallel lines and transversals. And there's a lot of names, so writing it down just helps it go into your memory better. The more you write it down, the more you will remember it, because the more you use it, the better your brain will remember why you wrote it down. All right, so two parallel lines, G and H, so they have them labeled here. Here's G, here's H, are cut by a transversal D. So here's D right here, as shown. So parallel lines, remember those, that means that they'll never intersect. They're always the same distance apart. So if they never intersect, but they're not the same distance apart, so you can actually have on different planes, like I have the pencil here, and let's say I had another line like this, my finger's another line going this way. Well, these are lines that would never intersect, but they're also not parallel. One's going up and down, one's going side to side. This is called skew. But if we have them parallel, so they're going the same direction, and they're always the same distance apart, they never come together, we call those parallel. Transversal just means that it's a line that is crossing the two lines we're talking about. So D crosses over H and it crosses over G, which means that it is a transversal. All right, so complete the statements below. It says, we see angle 2 and angle 3 are blank. And since the lines G and H are parallel, angle 2 and angle 3 are blank. So the measure of angle 3 equals blank. So we're going to do a lot of fill in the blanks here. So when you get down here, all these bold words, we're going to fill these in. And that means that you need to know what all these relationships are. So I want to make sure really quick, we want to write down some relationships here. So we have corresponding angles. Oops, I forgot the word. Forgot to finish the word. Corresponding angles. Hopefully that's not too terribly bright green when you're looking at it. And corresponding angles are congruent. We've talked about this in the other videos. When I have a corresponding angle, what it means, and I apologize, those don't look terribly parallel, but we're going to pretend like these two are parallel. What it means is they're in the same position when we're talking about the parallel line and the transversal. So my transversal is going up and down, my two parallel lines, which again, we're going to pretend are actually parallel. So if I'm talking about this angle right here, this is on top of the parallel line and it's to the left of the transversal. So if I go to my other parallel line, I want to look for the angle that's on top of the parallel line and to the left of the transversal. So that's right here. So I can do the same thing, and every angle you choose in this situation has a corresponding angle. So if I choose, let's say this one right here. So this is on the bottom of my parallel line and to the right of my transversal. So I want to go to my other parallel line and I want to go to the bottom and I want to go to the right of the transversal. And there we go. It's right here. So I'm just putting the arc in between the two arrows I'm making. So once we know how to identify corresponding angles, it makes it a little easier because we know corresponding angles are congruent, which means they equal the same thing. All right. Vertical angles do not require parallel lines at all. So vertical angles don't require any kind of parallel lines. All it requires is that you have two lines that cross like this. So here we have two lines. Anytime two lines cross like this, you can go across the vertex, and those two angles are congruent. So that's all vertical angles mean. So I can go across this way, and then these two are congruent. So it's just going across the vertex, straight across. And all you need are two lines that crisscross like that. All right, so I'm going to erase that little diagram just so we have a little bit more room in here. What's the next one they give us here? Alternate interior angles. Okay, so if I have two parallel lines here, I was trying to draw those a little bit more parallel. It'll come out a little better. And here's my transversal going across like this. Okay, and that one was a bit wavy. So here's my transversal. So when I'm talking about interior, we're talking about the parallel lines. So interior has to do with this space in here. This is in between the parallel lines. So if the angles you're talking about are in between, then we call them interior. So this is an interior angle. This is an interior angle, interior angle, interior angle. If it's not in between here, so if it's in, dang it, let me erase that. If it's out here or out here, that's exterior. So we have 4 exterior angles in this situation. So these 4 angles are called exterior. So we know that it's called alternate interior angles. So alternate interior angles, and I'll write this out. I'm going to be a little bit lazy and write alternate interior. So I did alt, int, so alternate interior angles are congruent. Again, this one does require parallel lines. So does corresponding angles. Vertical lines do not require parallel lines. All right, so we know that they have to be inside somewhere. And then we have to deal with this word alternate. So alternate refers to this transversal here. What it means is it's just alternate means other or a substitution for it. But in this case, what we want for an alternate is opposite. We can think of opposite. So if I choose this one on top for my interior angle, then I want to make sure it's on the opposite side of this line, this transversal. So if this is on the top, then I want to go on the bottom. And I want to switch sides like this. So I don't want to go straight across. I want to go across and then slide over to this one. So these are alternate interior angles. And they are congruent. So I can do the same thing to this side. If I look at this angle, I go across and slide over. There's my other alternate interior angle there. All right, so now that we've covered a few, and we'll see if we have a few more to cover on the next page, we should be ready to start answering some of these questions to fill in the blanks here. So let's go ahead and look at what we have. All right, so we have 2 lines. Whoops, forgot to turn on my pen here. I'm going to switch to orange just because I feel like doing orange here. It's very carrot looking here with the green and the orange. All right, so we have 2 lines here. We have this transversal. That is not quite what it looked like. Still not quite what it looked like, but close enough. All right, so we have 3, 1, 2. This is line W, this is line U, and this is line V. So we have 2 parallel lines, U and V, and they're being cut by this transversal here. And sometimes, I know I've done this in class, where I've made the transversal a different color. I'm not terribly good at tracing on top of a line I've already drawn. See if I can go down. If not, I may just leave it orange. Nope, that looks a little too ugly. So I'm going to leave it orange just because I can't quite get it a different color there. So sometimes it is helpful to make them a different color just so that you can really quickly see, okay, these are my parallel lines in orange. This is my parallel line in a different color. I just didn't plan ahead on that one. So we're also going to suppose that angle 2 equals 140 degrees. So they gave us that up here in the given. So now down here in our fill in the blank, we need to start using our properties up here that we wrote notes on to answer the question. So we see that angle 2 and 3 are blank. So angle 2 and 3, if I'm looking at 2 and 3, so of the 3 things, we want to figure out which one it is. So it's not a vertical angle because that would be 1 and 2. So we may deal with that in a moment, but right now we want to deal with 2 and 3. So we know it's not vertical angles. Alternate interior angles, well, these are on the same side of this transversal W, so they're not alternate anything. So that leaves us with corresponding angles. We just need to make sure it's true. So angle 2, if I'm looking at the parallel lines, it's on the left side of my parallel line, and it's on the bottom of my transversal. If I look at angle 3, it's on the left side of this parallel line, and it's on the bottom of the transversal. So I can describe them in the same way, which does make them corresponding angles. So I come over here and I click corresponding. So it does look like in the list, which we may need to write that up top at some point. We have alternate exterior angles up here also. So we just don't have that on our list yet. And since the line U and V are parallel, we know that, they told us, 2 and 3 are, corresponding angles are congruent. So we write congruent. All right. And that means that 3, since we know 2 is 140, 3 is 140 degrees. All right, so we see that angle 1 and 2 are something. So we already talked about this because we went through the list. So these are across from each other like this, which makes them vertical angles. So as soon as you can cross the vertex like that, that makes them vertical angles. So we're going to choose vertical angle. And we know from our list over here, vertical angles are also congruent, which means that 1 is also 140 degrees. All right, so now we want to look at 1 and 3. So we are actually going to have to use this other definition that I haven't quite written up here yet. So I'm going to erase a bit of the top of my lines here just so that I have room to write another definition. Whoop. All right, so we have alternate exterior angles, and they are also congruent. So the reason I wanted to write this one down is we already talked about alternate. Alternate has to do with which side of this transversal you're on. So if we're on the top for the first one, so number 1 is on the top, then we want to cross over to the bottom for it to be considered alternate. So if we're not crossing over this line, then they're not alternate. Exterior, remember that has to do with if interior is inside of here, in between the parallel lines, then exterior means that it's outside the parallel lines. So 1 is outside, and then if I cross over and I go all the way to the other side for outside, then I find this 3. It's also outside the parallel lines, and it's on the opposite side of the line that 1 is. So 1 is on the top, 3 is on the bottom. So that makes those alternate in, that makes them alternate interior or alternate exterior angles. Because we know 2 equals 140, which is equal to 3, and 2 is equal to 1, which is 140, we know that these two have to be equal to each other. So this relationship, we can build this relationship from vertical angles and corresponding angles. So a lot of these relationships or properties are built off of each other. So we know that these have to be congruent to each other just from default. If 2 equals 3 and 2 also equals 1, well, then 1 and 3 have to equal each other. They have no choice. So we also know that they're alternate exterior angles because we just talked about that. So that's their name. The relationship between 1 and 3 is an example of the following rule. When parallel lines are cut by a transversal, and we just have to choose, it says alternate exterior angles are congruent, alternate exterior angles are supplementary. That's never true. Alternate interior angles are congruent. That's true, but it's not the case. Alternate interior angles are supplementary. That's never true. Corresponding angles are congruent. That's a true statement, but it's not this case. Corresponding angles are supplementary. That's never true. All right, so we just have to figure out which one is correct for this one. So we know it's alternate exterior angles, and alternate exterior angles are always congruent. So we click check, and ta-da, we have our answer. Okay, so let's keep moving on this one. So this one's just a bit wordy. There's not a whole lot of math to do on this one. It's just a little wordy getting through all of this. All right, so I'm going to scroll up. So here now I have my two parallel lines. I'm going to try to draw these nice and parallel. And this is S, and this is T, it looks like. And I'm actually going to try to remember to switch my color here. Yay! All right, there's my transversal. So this is what I like just because it's very easy to see. My two parallel lines in green, and my transversal here is in blue. I will write the numbers here in gray for whatever reason. All right, so we also are being told that angle 1 is 170 degrees. And I'm going to kind of squeeze that up and up here because I didn't give myself enough room. So now the first statement says, we see that angle 1 and angle 2 are something. So we need to go through and take a look at these. So if I look at angle 1 and 2, I can quickly relate them by crossing the vertex. As soon as I cross the vertex right there to find them. So remember, you can't cross the vertex and like turn. That's not an option. You have to go straight across like this. All right. So I know if I cross the vertex, then we call those vertical angles. So I'm going to click on vertical angles. Vertical angles are always congruent, like we have in our notes there. So if angle 1 is 170, then angle 2 is also 170 degrees. All right. Now it wants us to say angle 2 and angle 3 are something. So we know they're not vertical angles because we can't go across a vertex. We know they're not alternate because they're both on the bottom side of that blue line. So they're not going to be either one of the alternates. So our other option here is corresponding angles. So angle 2 is on the right side of the parallel line and it's on the bottom of the blue line. Angle 3 is on the right side and bottom. So I can describe them in the same way. They're both on the right side of their parallel line and on the bottom of the transversal. That's all it means to be corresponding, is they're in the same position. So I can describe them in the same way. I have to get rid of my arrow. Okay. Okay. So I know that these are corresponding. Corresponding angles are always congruent. So that means if angle 2 is 170, which we just answered that right up here, then angle 3 has to be 170 as well. So therefore, angle 1 and 3 are congruent. If angle 1 is equal to 2, and then 2 is equal to 3, this is actually what we call the transitive property, because I can jump from the beginning, angle 1, to the end, angle 3. I can just cut out that middle 2 because they're both equal to 2. So I know that they're congruent. And if I take a look at them for the relationship, because this one wants a relationship, angle 1 is on the outside of the parallel lines, because remember, this is the inside here. So it's not in here. It's on the outside. It's exterior. And it's on top of the blue line. So if I drop to the bottom and I go all the way to the outside, there's angle 3. So these are alternate because they're on different sides of the blue line, and they're exterior. So we have alternate exterior angles. Alternate exterior angles. So this one is building the idea of how we get to this alternate exterior angle. So we have 1 and 3 is an example of the following rule. When parallel lines are cut by a transversal, alternate exterior angles are congruent. Uh-oh, what did I type wrong? Uh-oh, this said 70, not 170. That was a silly mistake, darn it. Ta-da, we got it right. All right, wasn't necessarily wrong. It was just, well, that is wrong. I wasn't paying attention and I wrote the wrong number. So even though I did everything correctly, I related all the angles, I didn't write the problem correctly in the first place. So it does make it wrong. All right, so here's parallel U. There's a very ugly line there. Here's U. And here's V. And I'll switch over to blue here for my transversal. There's K. All right, so I will write everything else here in gray, and I will pay attention. So angle 1, it says, is 45 degrees. So definitely 45 degrees, not 145 degrees, 45. All right, so now the first thing it says is angle 1 and 2 are, well, I know I can cross that vertex. As soon as I cross over that vertex, I know they are vertical angles. So I'm going to click on vertical. And I know vertical angles are always congruent. So angle 2 must also be 45 degrees. All right, so now we see that angles 2 and 3 are, so we know 2 and 3, let me erase. Oh, got rid of my 45 over here. So I know that angle 2 and 3 are not vertical angles. I'm not going across a vertex. They're also not alternate because they're on the same side of that blue line. They're both kind of to the right side of the blue line. So that gets rid of these bottom 3. So that brings me to corresponding angles. And I can check that by just making sure I can describe them the same way. So I'm to the right side of the blue line, and I'm on the bottom of my parallel. For this one, I'm on the right side of my transversal. I'm on the bottom of my parallel. So I can describe them the same way. That makes them corresponding angles. And I know corresponding angles are always congruent. So 3 must also be 45. So if 1 is equal to 2 and 2 is equal to 3, we can do that transitive property again, get rid of the 1 or the 2's, and I can say 1 and 3 must also be congruent. And 1 and 3, so this is, we haven't practiced this one yet. So this, remember, this is interior. So we know we're going to have some kind of interior reason for this. And then 1 is on the left side of the blue line. Blue is on the right side. So if I go from the right side and I go to the left side and I slide up, remember it's not the one directly across. I have to, without making a mark here, I have to slide up to this one. That makes it alternate interior angles. So, I already clicked congruent. So these are alternate interior angles. So the relationship between 1 and 3 is an example of the following rule. When parallel lines are cut by transversal, we know they're alternate interior angles. We just have to choose the correct one. It says alternate interior angles are congruent. That's true. The other option is that they are supplementary. That is never true. Alternate interior angles are always congruent. Check. Yay. Okay, one more. We should be done with this one, but I made that silly mistake on the first one. All right, it's always okay to practice more. If you get them wrong, there's nothing wrong with getting 1 wrong or 2 wrong and having to try it a couple extra times. It's just about learning the topics here. So if you have to try it a couple extra times to get it right, that is perfectly fine. Always make sure that you are writing notes and so that you can keep up with what's going on. Because without some of these notes up here, you may not remember some of the names, okay? All right, so I kind of switched my colors up here, but that's all right, as long as they're different colors. So I have my parallel lines in gray. Here's my transversal in blue, and I have angle 2, 1, 3, and they're also telling us that angle 2 is 115 degrees here. That's my little arrow. All right, so the first thing it says is 2 and 3 are, and I can see that 2 is on the top of the blue line to the left of the parallel. Blue is also on top of the blue line and to the left of its parallel. So from what we've practiced, I know that is a corresponding angle. And corresponding angles are always congruent. So 3 must be equal to 115. Angle 1 and 2 are, I can go across the vertex here. As soon as I go across the vertex, I know those are called vertical angles. Vertical angles are always congruent. So angle 1 must also be 115. And this is one of those things, it goes angle 2 is equal to 3, angle 1 is equal to angle 2. So even though it's not from beginning to end, they're both equal to angle 2, so they must also both be equal to each other. They're all equal to 115, so they're congruent or equal to each other. And then we can see the relationship here. So 1 and 3, they want us to describe this relationship. Remember, this is interior. And they are on alternate sides of the blue line. 1 is on the bottom, 1 is on the top. So if I have angle 1 and I go to the other side of the line, I need to slide down. There's 3. So that makes them alternate interior angles. So the relationship between 1 and 3 is an example of the following rule. When parallel lines are cut by a transversal, Alternate interior angles are congruent. Check. Yay! We finished another one.